Example problem 5 is very similar to example problem 4. The problem reads, a bubble of water with a surface tension of 0.095 Newton meters forms such that it has an integral gauge pressure of 15.1 pascals. A is asking us how large is the bubble, so they're asking us for the radius. We're being told that we have a surface tension of 0.095 Newton meters and that we have a pressure of 15.1 pascals. And so the formula that we're going to use for this equation is radius equals 4 times surface tension divided by pressure. And this is after the algebraic rearrangement that we saw in example problem 4. So if you need to reference that rearrangement, you can go back to example problem 4 and watch that video again. So filling in what we know here, 4 times 0.095 Newton meters divided by the pressure of 15.1 pascals. And you can put it into your calculator just like that. So 4 times 0.095 divided by 15.1 is going to equal a radius of approximately 0.025, so 0.03 meters for question A. And that is going to be your radius. So question B says that a surfactant is added to the water, reducing the surface tension to 0.076 Newton meters. If the gauge pressure inside the new bubble remains the same, what would the radius be in this case? So again, radius equals 4 times the new value for our surface tension, which is 0.076 Newton meters, divided by pressure, and it says that the gauge pressure remained the same, so we're going to use this value again, 15.1 pascals. So 4 times 0.076 divided by 15.1, that equals a radius of approximately 0.020 meters for part B. Thanks, and let me know if you have any questions about example problem 4 or example problem 5.